Welcome. Today is Tuesday, December 15th, and today we're going to be studying lesson 17, which is interpreting remainders in division. So we're continuing to work with division, and we're continuing to learn about interpreting remainders in division. Now, the next couple of slides I have here for you to be able to show your work. If you're doing work in the binder, if your teacher has you specifically doing work in the binder, this is where you can place your work in the binder. From the binder rather. On the next slide, this is your multiplication table. This is just here for you as a resource for you to be able to go back to, just in case you forgot your a certain math fact, but you're still practicing your math facts. Our essential question for this unit: why is it important to approach problems using a variety of strategies? Our learning target: I can solve division problems and interpret remainders, explaining reasoning. Playing with remainders. Now, the most important thing to remember about remainders is to look at what the question is asking you. Important details that you should be considering: look at what each number in the problem stands for, and this is for any word problem. Look at what each number in the problem stands for, and when you get a quotient, refer back to the problem to figure out what the quotient actually represents. And we've talked about this before, but there are 4 different ways of interpreting a remainder. You add it, keep it, drop it, or you use it. So add it, keep it, drop it, or use it. And we'll continue to learn about those 4 ways. The first one, round up. So sometimes when you get a remainder, you need to round up. And the next slide is going to be a problem where we have to round up. On this particular slide, there are 4 questions. Now, the first one, number 1, 23 people went to the family reunion. If 5 people could fit into each car, how many cars were needed to take people to the no remainder ranch? Number 2, at the no remainder ranch, 4 people were assigned to each cabin. How many cabins were needed for the 23 people? Number 3, while they were at the ranch, the family members went to a river rafting trip. If 6 people could fit on each raft, how many rafts were needed for the 23 people? Number 4, why did Tyler and Nikki have to round up the remainders each time in this story? So we're going to pause the video right here for a few minutes. While you're paused, make sure to go back and reread each question and solve them. Just clicking on the inside of these rectangles, and you can type your answers inside of the rectangles. And we're going to go over this in just a few minutes, but make sure to pause the video. Okay, so this is my answer key to each of those problems. Number 1, the equation would be 23 divided by 5. When you do that division problem, it's 4, but you have a remainder of 3. But they would need 5 cars, but you don't leave anybody behind. So you need 5 cars to take everybody. On the second one, 23 divided by 4 is 5 with a remainder of 3. However, you will need 6 total cabins to accommodate everybody. On the third one, 23 divided by 6, the answer will be 3 with a remainder of 5. Well, in this case, they would need 4 rafts. They would need 4 rafts in this case. And number 4, the remainder must be added as another group in order to take care of all parts of the problem. So the next set of questions are going to be answered by us having to just drop it. This is where you just drop the remainder. Okay, so let's go to our next slide, and there are 4 questions on here. Once again, we're going to pause, and I want you to go through and read each one. And once you've done so, just click inside of each rectangle and answer them. So you've had an opportunity to go through and answer those problems, question number 1 through 4. So now we're going to go over them. Number one, how many bunches of 7 flowers could Shaylee and Marisol make with 37 flowers? Now, your equation is 37 divided by 7, and the answer is 5, but there's a remainder of 2. So they can make 5 bunches. So they can make 5 bunches. Okay. And remember, they're making bunches with 7 flowers, not with 5, but with 7. So 5 is not enough to make another bunch. So that's, in this case, it's not useful. Number 2, how many plates of 6 brownies each could be made with 34 brownies? So how many plates of 6 brownies each could be made with 34 brownies? 34 divided by 6 is 5, and there's a remainder of 4. They can make 5 plates. So a plate, remember, has 6 brownies on it. It doesn't have 4 on it. So the remainder of 4 is not enough to make up a plate. So there are actually 5 plates. Number 3, how many plates of 8 cookies each could be made with 50 cookies? Our equation, 50 divided by 8 equals 6, but it has a remainder of 2. And so they can make 6 plates. That remainder of 2 is not enough. You need 8 cookies on each plate. So you need 8 cookies on each plate, so that remainder of 2 cookies does not count towards that. 4, why did Shaylee and Marisol have to drop their remainders each time in this story? The problem doesn't make use of a remainder in the overall context of the situation. That's why we said drop it for this. So for our next set of questions, we're going to utilize the strategy of sharing is caring. So sharing is caring for our next slide. So let's go and go to the next slide. And we've got 4 questions on this slide. So same thing. You're going to read each one. And inside of the rectangle, make sure to click. And that's where you put your answers. So in the rectangle, this is where you click. And this is where you put your answers for each. So pause the video and you can continue with the video once you have answered the questions, and we'll review it. Okay, so now we're going to review these. Number 1, Scott and Travis cut an 11-foot rope into 2 equal pieces. How long was each piece? So the equation here, 11 divided by 2 equals 5 with a remainder of 1. So each piece was 5 1/2 feet. So again, they cut an 11-foot rope. So the rope was 11 feet. And you divided that into 2 equal pieces. So when you do the division, it's 5 with a remainder of 1. So half of 1 is 1/2. So half of 1 is 1/2. So each would be 5 1/2. Number 2, 4 boys are sharing 17 airheads equally. How many airheads does each boy get to eat? So 4 boys are sharing 17 airheads equally rather. How many airheads does each boy get to eat? So the equation here, 17 divided by 4 equals 4 with a remainder of 1. So you got 4 each, but there's 1 left over. So with that 1 left over, what do we do with that? Let's split that 4 up. Let's split that 4 up, and it's going to be 1/4 plus 1/4 plus 1/4 plus 1/4 each. So each boy will get 4 1/4 airheads. 3, why didn't the remainders in the story need to be rounded up or dropped? Well, the remainder must be shared with measurement for precision or for fairness in the context of the problem with food. It may result in a fraction or a decimal. So write a good rule for what to do with remainders. So when you need to round up the remainder, when you can't leave people, animals, or things out. So when you need to drop the remainder, it's in most situations where when there is a restriction that prevents you from rounding up or sharing the remainder. When you need to share the remainder equally, often used with leftover money, food, or measurement, much like for the questions 1 through 3 on this slide. So on our next slide, this is introducing us to a Jamboard that we have. So we have a Jamboard, practice interpreting remainders in division. So this is the Jamboard that you have for independent work. It's got the first one here starts with Ahmad, and you've got a second one. Number 2 starts with Kevin. The third one, Carlene. And the fourth one, Woodfield Elementary School. So you're going to type, for each one, you're going to type your equation inside of on the sticky note, and you're going to type in what strategy you use right here. And over here, this is where you show your work. Show your work right here. And lastly, our last slide, reminder of your independent work to complete the Jamboard. Complete the Jamboard, and also 15 minutes of Dreambox. 15 minutes of Dreambox.